Hello everyone, very good morning. I hope you all are good. So today in the class, first we will be solving some questions from the previous portion, that is KTZ in thermodynamics. And after that, we will be moving forward with today's topic, that is your electrostatics and gravitation combined. Okay. So without wasting any seconds, let's start doing questions. Okay. Take your time, do this question. I will be launching the code. Everyone do it. You know the formula of RMS speed, right? Vrms is equal to what? 3 RT by M, where M is molar mass, T is temperature in Kelvin, R is gas constant. Or it can be written as 3 kT by small m, where K is Boltzmann constant, small m is mass of one atom or molecule. Okay? We often use this formula. Done it? So, yeah, do it, let me know. Just putting the formula, getting the answer type questions. Okay, nobody answered. Let me know if you're getting the answer. Okay, one answer I got, but it doesn't look correct. Let us end the poll and do the questions. That sort of question you should not fail in doing. I mean, this is simply putting the formula, getting the answer type question. So you have to be attentive with whatever question is coming on the screen, because this will translate in the same way in your examination hall. So it's very important that you practice it right away. I mean, there is no more time left. Yes, Punit, that's great. Thank you. So the temperature of gas is minus 50 degrees centigrade. To what temperature gas should be heated so that RMS speed is increased by 3 times. So let's say RMS speed initially is V1. V1 will be equal to 3R by M. Temperature is minus 50 degrees centigrade. I always told you कि temperature को Kelvin में लिखना है. So write it in Kelvin. 273 plus minus 50 degree. यानी कि 50 degree minus होगा. So how much value you are going to get? That will give you 223. So 223 Kelvin. Okay. Now RMS speed is getting increased by 3 times. So now you will write 3R by N, that is a constant for a particular gas sample. And let's say temperature is T. So divide it. What you are going to get? 1 by 3 is equal to root under 223 by M. So if we square on both sides, sorry, not M, but T. If you square on both sides, T will be equal to 9 into 223. So now if you're going to multiply it, how much value you are going to get? This will become 7 and this will become 0 and again this will become 0. 2007. So nothing of this sort we are getting. This is minus 50 degree, it is written, right? Okay. Is there any calculation mistake I did? Because we are not getting answer, right? This is in Kelvin. So we need to change it to what? We need to change it to, because 2007 Kelvin is not in the option, right? In the option 3097 Kelvin, which we are not getting. This one we are not getting. So we need to convert it to what? Degree centigrade. And for that, we need to subtract it by from 273, right? So then also you won't get the answer because कहाँ गलती किया मैंने? अच्छा श्रुति, दैट इज 324, बट यहाँ पे माइनस दिया हुआ था ना, इसलिए मैंने ये किया, बिकॉज 0 डिग्री सेंटीग्रेड इज इक्वल टू 273 केल्विन, राइट? So maybe there is printing mistake in the question. This is not -50 but +50. Then only this is possible. क्योंकि if it is -10 डिग्री सेंटीग्रेड, then it will be equal to how much Kelvin? Then for that we need to subtract it this way, right? We cannot do 273 plus 10. Then that will give us 283 Kelvin, and that will be true for 10 degrees centigrade. If it is -10, then there is problem. Yes, Punit. 3568 Kelvin you will be getting for temperature 50 degrees centigrade plus 50 degrees centigrade, right? So maybe there is printing mistake, I guess. So what you people are saying, according to that, 3V1 is equal to root under 3R by M. Temperature, if it is plus 50, then 273 plus 50. So you will be getting, sorry, this is 3 and this is 323, right? So this is 323, if I'm not wrong. 24, how you're getting, Shruti? That is 273, right? Yes, आपने कुछ गलती किया है. 3R/m into temperature T. So now if you will solve it and square the both side, 1/9 is equal to 323 by T. So temperature will be equal to this. And how much? How everybody is getting this thing? I mean, Shruti, how you got 324 Kelvin? 273 plus 50? That should be 323, right? क्या कर रहे हो सभी लोग? Can anyone unmute yourself and let me know? This is 2907. Why I'm getting such answer? I'm really confused. I mean, we just need to put in the values. Can anyone unmute yourself and let me know, please? Question is too simple. Yes, somebody showed me the diagram. ठीक है, दिख नहीं रहा है पुनीत सही से. जल्दी करो, फास्ट करो यार. Maybe I'm getting stuck somewhere. Okay, I need to look at my own calculation then. Give me some time. देखो, this is such a simple question, but still, let me. Okay. What mistake I'm doing is speed is not getting increased to 3 times. It is getting increased by 3 times. देखो क्वेश्चन पढ़ने में गलती किया मैंने. So RMS speed को 3 times बढ़ा है. It means initially if it is V1, then finally it is V1 plus 3V1, right? So this will become then 4V1. डन है. हमने मिस्टेक यहाँ किया था. This will be 4V1, right? So -50 ही करके चलते हैं क्योंकि क्वेश्चन में वही दिया है. ठीक है, everyone got it? What is the question given here? Question is, at what temperature the RMS speed will get increased by 3 times? So if initial RMS speed is V1, final RMS speed will be uh, get increased by 3 times. It means it will become V1 plus 3V1. Okay. So let's say V1 is at temperature -50 degrees centigrade. So here you will write 3R by M, 273 minus 50, right? Divided by 3R by M root under in temperature T. Okay. So 1/4 is equal to 273 माइनस 50 करोगे कितना जाएगा? सो दिस इज 3 and this is 2 and this is 2 divided by t. अगर आप स्क्वायर करोगे, if you are going to square it, no sorry, एक सेकेंड, दोनों साइड स्क्वायर कर लो, इधर तो रूट है ना, स्क्वायर तो नहीं होगा, रूट हट जाएगा, सो दिस इज दिस एंड दिस विल गेट स्क्वायर्ड. सो t इक्वल टू 223 इंटू 16. 223 इंटू 16 को आप मल्टीप्लाई कर लो, हाउ मच वैल्यू यू आर गोइंग टू गेट? You will be getting this much. So this is 3468 Kelvin, right? 3468 Kelvin. So 3468 Kelvin is not in the answer. So let's check in degree centigrade. So 3468 minus 273 and then you will be getting answer 3295 degree centigrade. Option A. तो देखो क्वेश्चन को ध्यान से पढ़ना कितना जरूरी होता है. मैंने अभी अभी गलती किया क्योंकि मुझे ऐसा लगा velocity is getting increased to three times of the initial one. No, it's getting increased by 3 times. So basically V1 में add होगा 3 times of V1 or V1. Then so that will become 4V1. So we have to be careful while reading the questions. Sorry, I ate a lot of your time. Anyway, let's do it fast. Let's be careful in the class, ठीक है? चलो, take your time, do it. This is also putting the formula, getting the answer type question. What is the formula of efficiency in terms of temperature? It is 1 minus T2 by T1. T2 is what? Lower temperature. T1 is what? Higher temperature. So T2 is temperature of sink. T1 is temperature of reservoir. ठीक है? ओके, ऐसा लग रहा है क्या? 3468 मैंने सही से ये किया है ना? कहीं कैलकुलेशन में मिस्टेक हुआ होगा, चेक कर लो एक बार. एक सेकेंड, मैं खुद से चेक कर लेती हूँ वहां पे जो मैंने पहले कर रखा है, ठीक है? देन आई विल लेट यू नो. इस क्वेश्चन को करो पहले एंड लेट मी नो. Yes, everyone done with this question? Why couldn't answer it? को कर, how much? It has efficiency of 50%. What does it mean? इसका सिंपल मतलब ये है कि एक सेकेंड, इसका सिंपल मतलब ये है efficiency is 50% means 50 by 100, it means half is the efficiency. So this will be equal to 1 minus T2. Source temperature is 327. Temperature of sink पूछ रहा है कि T2 is getting asked. T1 is how much? 327. Again, you need to change Kelvin. So अगर आप इसको केल्विन में कन्वर्ट करोगे, this will become how much? 0.06, right? So this is equal to how much? Again, half is equal to T2 by 600. ठीक है? and T2 will be equal to how much? 300 Kelvin. And if it is 300 Kelvin, then in degree centigrade, it will become how much? It will become, yes, Punit, it will become 27 degrees centigrade. Done? So this will be the answer. क्या है यार, प्रीवियस वन का लोचा नहीं समझ में आ रहा है. सारी चीज मैंने सही करी है. 2 2 3 और इसको ऐड कर, यहाँ पे मिस्टेक किया मैंने. 3, व्हाट इज दिस हियर? 8 3. मैंने बोला ना तुम लोग कैलकुलेशन को थोड़ा ध्यान से देखो. तो नहीं, मे भी आंसर में कुछ गलत दिया हो, क्योंकि 3468 ही तो आएगा. किसी का और कुछ आया क्या? 3568. मुझे तो 3468 दिख रहा है. अरे यार, मल्टीप्लीकेशन में गलत है ना. दिस इज 1338. सो हियर इट विल बी 3568. So here it is 3568, and in that case you will get this 3295 degrees centigrade. Calculation check कर लो ना थोड़ा. Done है. Conceptually you need to go like this. चलो let's do this question fast. Let me know. Yes, पुनीत, multiplication में बनो. क्या होता है ना, एक बार चीजें गलत हो जाती है तो गलत ही होती रहती है, इसलिए थोड़ा कैलकुलेशन में तुम लोग साथ दिया करो whenever I am getting it wrong. ठीक है. चलो let me know fast. Yes, now you can vote in the poll also. Which curve will represent adiabatic process? This is the question. ठीक है. Okay, so many answers, all different answers almost. Out of those 7, 2 is correct. Okay. Okay, let me end the poll क्योंकि इसमें ज्यादा कुछ करना है नहीं. You have to just look at an answer. क्योंकि if you know what is the difference between adiabatic, isothermal curves and all, you will be able to answer it within some seconds. So let us discuss this. There are 4 curves, right? This is a PV curve. So curve 1 की अगर आप बात करो तो along 1 pressure is remaining constant. So 1 definitely is your what? 1 is your isobaric process. Yes, Punit. Raju, yes. So 1 is your what sort of process? Isobaric. Done है? So this is isobaric. If you talk about 2, so sorry, isochoric. देखो आज मेरा दिमाग कहीं और है. I'm really sorry. Somewhat I'm distracted. I don't know what's the reason, but I am somewhat. Process 1 में क्या है? Volume constant रह रहा है ना? If you look at process 1, throughout this point is constant. V coordinate का point is constant. So volume is constant. This process is isochoric, not isobaric. If you look at process 4, let's talk about 4 first. So for 4, what is common? Pressure at each point is same. So this 4 is a isobaric process. Now we have 2 curves which are not straight line, right? They are curved like this. So one will be isothermal, another will be adiabatic. So you must have read PV curve for isothermal and adiabatic. For isothermal, it is like this, and also for adiabatic, the curve is like this. But if you have to draw them together, अगर एक साथ आप draw कर रहे हो, then adiabatic curve is more steep and isothermal curve is less steep. Done it? So out of these two, अगर मैं बोलूँ ये 1 है, ये sorry इसको A बुला लो, इसको B बुला लो, which is more steep? B is more steep, right? More steep, how you will determine? Just you sit here and see in which case you will slip more. So in B case you will slip more. So B is more steeper. Done. And so this will be adiabatic. Now coming back to here, 3 को अगर आप देखो, this is less steep, 2 is more steep. So 2 is your adiabatic and 3 is your isothermal. Why adiabatic is more steep? Because in this case, slope of the curve, yaad rakhna, slope of the curve is minus gamma delta P by delta V. And in this case, slope of the curve is minus delta P by delta V. So in adiabatic process, slope is by gamma times more deeper. And we already know gamma is greater than 1. ठीक है? So adiabatic slope is more deeper. सॉरी मोर स्टीपर. तो याद रखना. चलो इसको जल्दी से करके बताओ सभी लोग फास्ट. ठीक है, टेक सम टाइम एंड लेट मी नो. यस मैं डोलू. वन का 2. यस यू कैन आंसर इन द पोल ऑल्सो. ठीक है, बिकॉज दैट इज मोर कन्वीनियंट ना. चलो ना, नाउ आई एम लॉन्चिंग द पोल सो दैट यू कैन आंसर. Okay, I got 2 correct answers. Overall 4, overall 5, 7, 4 correct answers. Great. चलो सही है. Everyone else come forward, vote. Yes. Okay. 50% of you are correct. Chalo, let me end the poll and let me show you. This is just a formula based thing. Root mean square speed. Root mean square speed को आप क्या बोलते हो? Root under 3 RT by M, that is RMS speed, right? So option A के लिए क्या करेक्ट होने वाला है? ऑप्शन ए के लिए Q. ठीक है. उसके बाद अगर आप ध्यान से देखो, यस देखो, प्रेशर एक्सर्टेड बाय आइडियल गैस. तो प्रेशर एक्सर्टेड बाय आइडियल गैस का फॉर्मूला क्या होगा? इफ यू रिमेम्बर दिस काइनेटिक थ्योरी ऑफ गैसेस थिंग, सबसे पहला डेरिवेशन जो हम करते हैं वो ये होता है, प्रेशर एक्सर्टेड एट माइक्रोस्कोपिक लेवल इज रिटन एज 1/3 NM V RMS का स्क्वायर. ठीक है, where n is number of molecule per unit volume, m is mass of single atom or molecule. So definitely B का ऑप्शन क्या होने वाला है? P. If you talk about C, average kinetic energy of a molecule. So molecule का average kinetic energy क्या होता है? सिंगल मॉलिक्यूल का. ठीक है, ये 5/2 RT भी लग रहा है क्योंकि वो मॉलिक्यूल डायटोमिक भी हो सकता है. सो सी थोड़ा कंफ्यूजिंग लग रहा है, डी पे चलते. टोटल एनर्जी ऑफ 1 मोल ऑफ ए डायटोमिक गैस, इसका तो श्योर है कि 5/2 RT होगा. देन वी आर लेफ्ट विथ ओनली वन ऑप्शन, दैट इज एस. सो सी के लिए एस करेक्ट होगा. एंड फॉर डी व्हाट विल बी करेक्ट? फॉर डी आर विल बी करेक्ट. सो दिस इज गोइंग टू बी योर आंसर. ठीक है, चलो. चलो ये तुम लोग कर लेना, इसका स्क्रीनशॉट ले लो एंड डू दिस क्वेश्चन. सिंपल है. आइडियल गैस इक्वेशन यू हैव टू यूज. सिलेंडर कंटेन्स हाइड्रोजन गैस एट a pressure this and temperature this. Then you have to talk about density. So ideal gas equation you will simply use, and from here you can calculate density क्योंकि mole can be broken into mass by molar mass, and mass by volume you can write as density. So you can calculate this thing, right? So these were all the questions. We have already done some questions before, right? So let me share the today's slide. आज जो हम पढ़ने वाले. तो आज हमारा टारगेट क्या था? टुडे वी हैव टू लर्न इलेक्ट्रोस्टैटिक. लर्न क्या करना है? वी हैव टू रिवाइज. ठीक है, इलेक्ट्रोस्टैटिक्स एंड ग्रेविटेशन दोनों को साथ में लिया है क्योंकि दोनों के फॉर्मूले में काफी ज्यादा रिजेम्बलेंस है. ठीक है, तो चलो स्टार्ट करते हैं. सो लेट्स स्टार्ट विद द बेसिक थिंग. क्या क्या हमें देखना है? कूलम्स लॉ, whatever things in our syllabus that we will have a look over. Coulomb's law, electric field, electric flux, Gauss law, electric field due to continuous charge distribution. All formulas we will see. Electric field due to dipole. So अगर तुम पढ़े हो Coulomb's law defines force between charges. So that formula is written like this. Similarly, in gravitation, if we have two masses, force acting is always attractive in this case. Here it can be repulsive or attractive depending on both are positive, or one is positive, another is negative, or both are negative, right? So similar charges, repulsive force, opposite charges, attractive force. Here, force is always attractive. So clear resemblance you can see. Q is getting replaced with mass. G is getting replaced with K. Otherwise, it is also inversely proportional to distance का square, and here also. ठीक है? After that, if we talk about field, for a point charge at distance r, field is written in this way. And also for mass, any mass m, for which if we have to define gravitational field at a distance r, then it can be written like this. Similarly, potential for charge q at a distance r, it is kq by r. If charge is negative, then potential at distance r will be also negative. Okay? But in case of what? In case of mass, since force is always attractive, this potential thing will be always negative, minus gm by r. So formula same दिख रहा है ना? Non-conducting sphere we have studied, means some sphere that is not conducting. For this case, electric field for any outside point is kq by r square. And similarly for earth at a distance r, ठीक है, if we have to define gravitational field, we can write it like gm by r square. इसको अगर आप रेडियस ऑफ अर्थ लिखो तो gm by r square को what you can write r plus r का होल स्क्वायर. ठीक है, सॉरी, ये r ले लो और ये h हाइट पे ले लो, so this will become r plus h का होल स्क्वायर. And if h is far less than r, then we can approximate this thing to this thing, 1 minus 2h by r. So if you are calculating gravitational field at certain height, such that that height is very smaller than that of radius of earth, then gravitational field at that point can be written as 1 g into 1 minus 2h by r. ठीक है? That can be written as what? G into 1 minus 2h by r. Similarly, if you talk about potential, for outside point, it is kq by r, and here also it will be minus gm by r. Done it? If we talk about electric field on the surface, so this will be kq by r square, and here it is gm by r square, जिसको हम कितना बोलते हैं, 9.8 meter per second square. Similarly, gravitational potential, if we talk about, so at a point on the surface of earth, it is minus gm by r, and for this non-conducting solid sphere, it is this. ठीक है? And if we go to any inside point, electric field is what? Rho r by 3 epsilon naught, where rho is what? Rho is charge density. So this is basically equal to this much. Okay? So rho r by 3 epsilon naught. Done it? अब आप देखो, अगर ग्रेविटेशनल फील्ड इनसाइड अर्थ की अगर आप बात करोगे, इनसाइड अर्थ की, देन सिमिलरली यू कैन ट्रांसलेट द फॉर्मूला. आर से ही रहेगा. रो, here it will also be rho, but here it is charge density, here it will be mass density. ठीक है? And 3 will be here. Epsilon naught will get replaced by what? So g k से replace हुआ था. It means g is getting replaced by 1/4 pi epsilon naught. Epsilon naught can be replaced by this. So I'm just showing this so that I can show you how much resemblance is there between formulas in electrostat and gravitation. ठीक है? So for any point inside Earth, g dash को हम क्या लिख सकते हैं? Rho, that is this, into r, 3 divided by this. So this is gm by r square into small r by r. And here gm by r square is equal to how much? This is equal to small g, gravitational field on the surface of earth. So this is basically equal to g into small r by capital R. ठीक है? And a small r can be written as what? अगर आप लोगों को पता हो तो हम लोग डेप्थ के टर्म में बात करते हैं कि ये पॉइंट कितने डेप्थ पे है. सो लेट्स से ऑन द फ्रॉम द सरफेस दिस पॉइंट इज एट अ डेप्थ ऑफ d. So this small r can be written as radius of earth minus d. So यहाँ हमने क्या किया? g into small r को लिख दिया radius of earth minus d divided by r. Then वहीं से ये फॉर्मूला आया है. So ग्रेविटेशनल फील्ड की अगर बात करूं तो सरफेस पे कितना होगा? अर्थ के सरफेस पे g, that is equal to how much? gm by r square. सरफेस के बाहर at any height h, g is equal to how much? g, sorry, कितना होता है, चलो फॉर्मूला को सही से याद रखना है. So that will be equal to g1 minus 2h by r. This is true when h is far less than that of capital R, and if it is not less, then simple formula लिखना gm by r plus h का whole square or gm by small r का square. And at any depth d, formula is what it is, g dash is equal to g1 minus d by r. So these three things you have to remember. If we talk about potential, electrostatic potential for any inside point, यहाँ से क्वेश्चन कम आता है, but this is the formula. ठीक है, this is the formula. चलो, so नॉन कंडक्टिंग सॉलिड स्फीयर के लिए हमने बात किया, बट इन इलेक्ट्रोस्टैट वी आल्सो स्टडी अबाउट कंडक्टिंग सॉलिड स्फीयर, कंडक्टिंग हॉलो स्फीयर, नॉन कंडक्टिंग हॉलो स्फीयर. जस्ट बैक में हमने किसके बारे में पढ़ा? नॉन कंडक्टिंग सॉलिड स्फीयर, नॉन कंडक्टिंग सॉलिड स्फीयर. सो उसके आउटसाइड पॉइंट पे के क्यू बाय आर स्क्वायर, ऑन द सरफेस के क्यू बाय कैपिटल आर का स्क्वायर, and at any inside point that was rho r by 3 epsilon naught. So these three formulas are true for non-conducting solid sphere. ठीक है? And if we have conducting solid sphere, conducting hollow sphere और non-conducting hollow sphere, इन तीनों के लिए फॉर्मूला सेम होगा. At inside point electric field is 0, on the surface it is this, and outside point this is this. So on the surface and outside point के लिए formula is same for four different spheres, right? Only at inside point is varies. For these three cases, at inside point electric field is 0, and for non-conducting solid sphere it is rho r by 3 epsilon naught. इसके ग्राफ से भी क्वेश्चन आया है, तुम लोगों को याद होगा. ठीक है. Now infinite seat के लिए भी हमें पढ़ना है. So if this seat is conducting, then electric field will be sigma by epsilon naught, and if it is non-conducting, then sigma by 2 epsilon naught. हमेशा याद रखना है ये सारे फॉर्मूलेस. ठीक है. उसके बाद इन्फिनिटली लॉन्ग वायर के लिए इलेक्ट्रिक फील्ड इज लैम्डा बाई 2 पाई एप्सिलॉन नॉट आर, वेयर लैम्डा इज चार्ज पर यूनिट लेंथ. ठीक है. गॉस लॉ क्या कहता है? गॉस लॉ टॉक्स अबाउट इफ it talks about flux. So flux through any closed surface, that is flux through any 3D surface, is equal to charge enclosed by epsilon, where epsilon is permittivity of the media. So अगर एक कोई भी random surface ले लो, इसके अंदर जो भी charges हैं, और let's take one charge outside Q3. So flux through this closed surface, flux will be equal to how much? Q1 plus Q2 by epsilon naught. Because sorry, epsilon, if this is not vacuum, then flux is always equal to sum of whatever charge is enclosed inside the surface divided by permittivity. So here there will be no net flux through the surface because of Q3. But if you talk about this equation, a certain reason में आ सकता है. If you talk about this equation, then here total flux is only because of inside charges, that is here Q1 plus Q2. But if you talk about electric field at any inside point, so that will be because of all three charges, inside, outside, both. Q1 की वजह से भी होगा, Q2 की वजह से भी होगा, Q3 की वजह से भी होगा. So always remember this thing. This whole thing, E dot ds, will be only because of inside charges. But if you go into E dot ds and you talk about only E, then electric field will be because of both inside and outside charge. You need to have this in your mind. Now, if you talk about potential energy, electrostatic potential energy we talk about. So this is if two system of charges are kept at separation r, it has certain energy which is written like this. Similarly, if two masses are at separation r, potential energy is written like this. Okay. Now, electric field due to dipole, you all must be having idea of on the axis. If this distance, let's say it is a, and from here this distance is r, such that r is far greater than a, then at this point electric field value is equal to k into 2p by rq, right? And direction will be in the direction of dipole. At this point, electric field at equatorial point, electric field is opposite to the direction of dipole. And here dipole direction is this. and here electric field value is K into P by R cube. So always have this in your mind. Now इलेक्ट्रिक पोटेंशियल ड्यू टू डाइपोल. सो अगर पोटेंशियल का फॉर्मूला याद हो तुम लोगों को, तो इलेक्ट्रिक पोटेंशियल ड्यू टू डाइपोल क्या होता है? एनीवन रिमेम्बर द पोटेंशियल फॉर्मूला? इट इज, देखो मेरे दिमाग से थोड़ा स्केप हो रहा है, पी डॉट आर, आई फील लाइक के पी डॉट आर बाई आर क्यूब. ठीक है. सो केपी कॉस थीटा बाई आर स्क्वेयर है ना. पी डॉट आर मतलब अगर तुम्हें कोई भी रैंडम पॉइंट पे पी, सपोज इस पॉइंट पे ओ पॉइंट पे निकालना है पोटेंशियल, एंड दिस थिंग इज थीटा and this distance is r, and this is your what, dipole moment. Done. So this is dipole moment. Potential will be what? P dot r. P dot r k p dot r divided by r cube. So it will become how much? K p dot r को क्या लिखोगे? P r cos theta divided by r cube. So this is kp cos theta by r square. ठीक है. This is your potential. बट वी नीड टू क्रॉस चेक इट. मैं क्वेश्चन करोगे उस समय क्रॉस चेक कर लूंगी, बट इट्स करेक्ट है. Now force, torque and potential energy and SHM. So let's have a look over it. Whenever you place dipole in a uniform electric field, that is, if electric field is value is same throughout the space, then whatever force is acting on the positive charge, same amount of force will act on the negative charge in opposite direction, and that is why net force acting is what? Zero. If kept in uniform field. अगर non uniform field है तो here force, electric field will be different, so force different, here also different, so force different, then non-zero. But in uniform field it will be zero. टॉर्क का फॉर्मूला हमने क्या पढ़ा है? टॉर्क का फॉर्मूला पढ़ा है P क्रॉस E. So P is dipole moment, E is electric field. What is the formula of potential energy? Potential energy का फॉर्मूला है minus P dot E. This is the formula of potential energy. Now this is SHM वाला thing. SHM में हमने पढ़ा है कि if there is a dipole placed in a uniform electric field and if we displace it from its equilibrium position, then it performs SHM. और उस SHM का ओमेगा कितना होगा? So you can simply how you can calculate it? जैसे देखो, okay, what will be the formula here? सो एक काम करो, टॉर्क से इजीली निकाल सकते हो. अगर मुझे फॉर्मूला याद नहीं है सो मैं डिराइव करके तुरंत बता देती हूँ. सो दिस इज टी ई साइन थीटा. टॉर्क इज आई अल्फा. सो दिस इज पी ई थीटा बिकॉज एस एच एम विल बी फॉर स्मॉल डिस्प्लेसमेंट. सो साइन थीटा को थीटा लिखा मैंने. अल्फा इज इक्वल टू पी ई बाई आई थीटा. सो दिस थिंग इज योर ओमेगा का स्क्वायर. सो ओमेगा इज पी ई बाई आई. आई इज व्हाट? मोमेंट ऑफ इनर्शिया ऑफ दिस रॉड. ठीक है. सो टाइम पीरियड क्या होगा? 2 पाई बाई ओमेगा, यानी कि 2 पाई आई बाई पी. अगेन डोंट हैव अ लुक ओवर दिस, यू जस्ट रिमेंबर द फॉर्मूला, क्योंकि उससे ज्यादा आएगा नहीं तुम लोगों को. ठीक है. सो इफ दे आर आस्किंग angular velocity of this rotating dipole, I mean this dipole performing SHM, then you will write root under P by I. Time period 2 pi root under I by P. मोमेंट ऑफ इनर्शिया कैसे निकालोगे? डाइपोल को रॉड की तरह ट्रीट, नहीं, रॉड की तरह ट्रीट करने की जरूरत नहीं है, बिकॉज देर इज वन मास ओवर हियर ऑफ minus q and there is another mass here of plus q. So we have one mass here m1, another mass here m2. Done it. So moment of inertia will be what? m1, if this distance is a, this distance is a, then moment of inertia is what? m1 a square plus m2 a square. ठीक है. Most probably that will be given already in your question. If not, you can calculate it like this. Okay. Now, electrostatics of a conductor. If there is a conductor and it is kept in electric field, अगर यहाँ पे electric field है और अगर इस electric field में आप conductor को रखते हो, then whatever field is there, that won't be able to cross the conductor. So conductor के अंदर हमेशा electric field क्या होता है? Zero होता है. And it has a meaning. इसका meaning ये है कि जो इलेक्ट्रिक फील्ड का डायरेक्शन होगा वो कंडक्टर के हमेशा क्या होता है? नॉर्मल होता है, परपेंडिकुलर होता है. इट विल नॉट क्रॉस द कंडक्टर, and so its electric field is what? Perpendicular to the conductor. I cannot go into reasoning क्योंकि अभी रीजन करने का टाइम नहीं है. अभी क्या है, हमें पता रखना है क्या क्या ट्रू. ठीक है. सो दिस थिंग नाउ. ग्रेविटेशन में क्या बचा हुआ था? केप्लर्स का लॉ. लॉ ऑफ ऑर्बिट क्या कहता है कि प्लैनेट जिस ऑर्बिट में मूव करते हैं उस ऑर्बिट को हम एलिप्टिकल ऑर्बिट बोलते हैं. दैट इज नॉट सर्कुलर एग्जैक्टली, इट इज एलिप्टिकल ऑर्बिट. सो एलिप्स में यू ऑलरेडी नो देयर इज वन मेजर एक्सिस. सो लेट्स से दिस इज मेजर एक्सिस एंड वन इज योर माइनर एक्सिस. ठीक है. सो मेजर एक्सिस का डिस्टेंस आप इसको 2a ले लो और इसको आप क्या ले लो? 2b. ठीक है. सो बेसिकली if we talk about sun, then sun will be at one focus of the ellipse and then planet will go round in the elliptical orbit. So this is the thing. What is this law of area? It says that whatever planet is moving, when it will keep on moving like this, it is traversing certain area. So aerial velocity, that is delta A by delta T, is always constant, and that is equal to angular momentum of this planet divided by 2 into m. So basically यहाँ पे जो दिख रहा है तुम्हें aerial velocity, this is constant. Law of area ये कहता है कि aerial velocity is constant. So this is constant. And when I'm saying कि aerial velocity is equal to L by 2m, it means angular momentum of this planet is also constant. यानी कि if this distance is r and this is the mass of planet, let's say, and this is the velocity v, then r cross mv, that is angular momentum, will be always constant. So with time r is changing. Sorry, ये दिक्कत हुआ थोड़ा. Just give me some time. So with time, what will happen? R will change, right? R हमारा क्या होगा? Change होगा. And velocity then will also have to change. Then is such that angular momentum will remain what? थोड़ा सा hang हो रहा है. एक second. So let me write it again. R mv को क्या रहना है? Constant. है ना? जैसे जैसे कि planet इधर जा रहा है, देखो R change हो रहा है. R change हो रहा है ना? सो m तो चेंज नहीं होगा, r चेंज हो रहा है. इसका मतलब किस चीज को चेंज होना चाहिए? वेलोसिटी को भी, सच दैट r mv विल रिमेन कांस्टेंट. सो आई डोंट नो व्हाई इट इज हैपनिंग. So what will happen as the planet will traverse the elliptical orbit, its radius is changing, and that is why its velocity is changing such that r mv will remain constant. So where r is greater, velocity will be less. Where r is less, velocity will be more, such that r mv is constant. यहाँ से भी क्वेश्चन आता है. Law of period, time period of this planet around the sun, t का square will be directly proportional to a का cube. Here A is what? A is the 2a is the length of major axis. So basically A is half of that. ठीक है. So ये चीजें आप याद रखो. ठीक है. Now what is this orbital velocity? So for any sort of calculation, we assume orbit is circular. So if we are assuming orbit is circular, then if there is sun here and there is planet here, and if you have to calculate orbital velocity, gravitational force will be responsible for letting it go round the circle. So this by radius का whole square will be equal to mass of planet v square by r. So if you calculate velocity, it will be equal to what? G into mass of sun by r. So this is your orbital velocity. What is the time period? Time period का formula आप निकाल सकते हो 2 pi r by v. क्योंकि time is time taken to complete one circle, that is to traverse 2 pi r distance with velocity v. So 2 pi r by v का वैल्यू हमने कितना लिखा? G m sun by r. So this thing you need to write there. उसके बाद है total energy of planets. So potential energy is, I mean, there is sun here and there is planet here. So there is two mass systems, sun and planet. So their potential energy at a separation r will be equal to how much? Minus g ms me divided by r. Kinetic energy will be half me into v square. Velocity अभी अभी हमने निकाला, put कर दो, you will get this as the answer. And total energy will be sum of kinetic energy and potential energy. So if you are going to add it, minus g me ms by 2r. So if you look at here carefully, magnitude of total energy and kinetic energy is same, right? So कभी कभी कंपैरिजन आ जाता है मैग्नीट्यूड में. नाउ व्हाट इज दिस एस्केप वेलोसिटी? अगर एस्केप वेलोसिटी आपसे पूछता है तो एस्केप वेलोसिटी का सिंपल मतलब ये है, if there is certain object kept on the surface of earth and if you have to escape it to zero infinity, it means you will give it as much energy. With that energy it will just leave the gravitational field of earth. So initially it is here, so when it will be on the surface of earth at rest, its energy will be minus gmm by r, and we are giving it certain kinetic energy so that it can escape to infinity. At infinity there is no potential energy because it is out of the effect of earth, so here potential energy is zero. And also we are assuming that here kinetic energy is zero because here we are giving it minimum kinetic energy so that it can just escape. So here kinetic energy will also be zero, so total energy zero finally. So initially also it has to be zero. So we are giving it as much amount of kinetic energy that when will get added to potential energy will become equal to zero. Okay. So from here, when you will calculate escape velocity in this scenario, you will get 2gr as the answer. ठीक है. और ऑर्बिटल वेलोसिटी का अगर तुम कंपैरिजन करते वहां पे तो वो आंसर क्या आता आपका? ओके, लिव इट हियर, कंफ्यूज हो सकते हो तुम लोग, सो लेट्स नॉट टॉक अबाउट. ठीक है, चलो. नाउ डू दिस क्वेश्चन एंड लेट मी नो. क्वेश्चन काफी इजी इजी है, इसलिए मैंने फॉर्मूला को ज्यादा टाइम दिया क्योंकि सारे पुटिंग द फॉर्मूला गेटिंग दैट आंसर टाइप क्वेश्चन है. ठीक है, यू डोंट हैव टू अप्लाई मच ब्रेन, इसलिए कॉन्सेप्ट का होना जरूरी है, फॉर्मूलेस का होना जरूरी है. सो जस्ट लुक एट द क्वेश्चन एंड लेट मी नो व्हाट आंसर यू आर गेटिंग. जो जो फॉर्मूला मैंने रिवाइज नहीं करवाया आई विल डू दैट थ्रू क्वेश्चंस. ठीक है. दिस इज अ स्फेरिकल सेल, है ना. वी आर गिवन 2 पॉइंट्स पी एंड सी. वी हैव टू कैलकुलेट पोटेंशियल डिफरेंस. सो पोटेंशियल डिफरेंस का फॉर्मूला अगर आपको पता है, यू विल बी एबल टू मेक द आंसर. वेरी गुड, 2 करेक्ट आंसर्स आई गॉट. ओके, 1 रॉन्ग आंसर जस्ट नाउ आई गॉट. एक बार चेक कर लो सही से, फॉर्मूला चेक करो. मैंने क्या बोला था? स्फीयर, हॉलो स्फीयर जो होता है उसके अंदर इलेक्ट्रिक फील्ड हमेशा जीरो होगा. और इलेक्ट्रोस्टैट में आप लोगों ने एक फॉर्मूला पढ़ा है, डीवी इक्वल टू माइनस ई डॉट डीएल. पढ़ा है ना ये फॉर्मूला? So if electric field is zero in this space, for that case dV will be zero. अगर अगर इनसाइड पॉइंट पे सपोज करो मैंने यहाँ पे एक पॉइंट लिया और यहाँ एक पॉइंट लिया अंदर, ठीक है, उसके लिए मैं डीवी कैलकुलेट कर रही हूँ. सो आई विल डू ई डॉट डीएल. ई इज जीरो, सो डीवी इज जीरो. It means potential at point 1 is equal to potential at point 2. Then only dV is zero, right? So V1 is equal to V2. And this value is equal to what? दीपू, एक बार ध्यान से देखो. यस पुनित. सो V1 is equal to V2 and this value is equal to potential at the surface. ठीक है. So यहाँ पे P point is on the surface, C point is at the center. So P and C will share same potential. C is an inside point. So at any inside point, potential is same as that at the surface. So if there are so many inside points, all these points potential is same, and that same potential is equal to potential at the surface. So C और P का potential same है, so potential difference will be zero. So correct answer will be 4. Simple formula based question. Now do this and let me. Yes, Sai, correct. Raju, Sai, yes, that's correct. राजू तुम एक बार चेक कर लो बी तुम कैसे बता रहे थे, अभी तो क्लियर होगा आई गेस. चलो, आई एम एंडिंग द पोल एंड लॉन्चिंग इट अगेन फॉर दिस. यहाँ पे भी तुम्हें कुछ नहीं करना, सिंपल कॉन्सेप्ट को आंसर करना है. सो जस्ट नाउ आई हैव डिस्कस इलेक्ट्रोस्टैटिक्स ऑफ कंडक्टर. फ्रॉम दैट ऑल्सो यू कैन डायरेक्टली आंसर. यस, आई गॉट 1 करेक्ट आंसर, 2 रॉन्ग आंसर्स. व्हाई? फ्लक्स किस चीज पे डिपेंड करता है? जस्ट नाउ आई हैव डिस्कस दिस क्वेश्चन. दिस केम इन प्रीवियस ईयर इटसेल्फ. सो फ्लक्स विल डिपेंड ऑन व्हाट? गॉस लॉ को याद करो प्लीज एवरीवन. यस, साई, नो. राजू नहीं, अभी अभी गॉस लॉ पढ़ा ना। गॉस लॉ ने क्या बोला? E डॉट ds, that is flux enclosed by the surface. This is flux, and this is always equal to Q enclosed by epsilon. So flux enclosed by surface depends on what? Depends on what? Depends on charge enclosed, right? Yes, पुनित। क्वेश्चन क्या था? अकॉर्डिंग टू गॉस लॉ, कहा भी है ना, गॉस लॉ के अकॉर्डिंग इलेक्ट्रिक फ्लक्स थ्रू ए क्लोज surface, that is 3D surface, depends on what? It depends totally on how much charge is sitting inside that closed surface. ठीक है? सो यस साई, नाउ इट इज करेक्ट। प्लीज यार छोटी छोटी चीजों को याद रखो, तुम लोगों को ज्यादा डिफिकल्ट क्वेश्चन आ नहीं रहा। सो यस राजू, दैट्स करेक्ट। सो प्लीज हैव दिस थिंग्स इन योर माइंड। अब ये क्वेश्चन भी बहुत इजी है, ये एनसीईआरटी में भी दिया हुआ है, हमने क्वेश्चन किया है क्लास में भी। सो नाउ डू इट एंड लेट मी नो द आंसर। That is why I said you 12th portion is much more easier than that of your 11th portion even. यहाँ तो सिंपल फॉर्मूला है and some repetitive questions which are coming time and again. चलो ठीक है, come on everyone. I got 4 answers. Out of that, 1 is correct. 2 is correct now. That's great. Okay. Only 2 correct. 8 answers I got. हम लोगों ने एक चीज पढ़ा। क्या पढ़ा? हमने ये पढ़ा, what is question given? Charge Q coulomb is placed at the center of a cube. So there is a cube. Cube को आप ऐसे देख लो। Done है? This is cube. And there is charge kept at the center. Done. Flux coming out from any of its faces will be. कोई भी एक फेस से फ्लक्स कितना आ रहा है? Yes, Sasank, that's correct. पुनीत, yes. अब देखो टोटल फ्लक्स क्या होगा। सो यूज गॉस लॉ, ई डॉट डी एस इज इक्वल टू क्या होता है? क्यू इनक्लोज, दैट इज क्यू हियर बाई एप्सिलन। सो दिस इज द एंड इट इज केप्ट इन अ वैक्यूम, सो एप्सिलन नॉट ले लेते हैं, आप ऑप्शन में यही दिया है। सो क्यू बाई एप्सिलन नॉट, दिस इज द टोटल फ्लक्स। नाउ दिस चार्ज इज केप्ट, is symmetric. I mean, all these 6 surfaces of the cube, है ना, एक डाउन फ्रंट 4 surfaces ऐसे, और एक अप एंड एक बॉटम, 6 surfaces are there in closed surface, right? So from all these 6 surfaces, charge is equal, charge is placed at a equal distance, यानी कि it is, there is a symmetry. Done. So whatever flux will go from this surface, same flux will go from this surface. So if there are 6 surfaces, let's say from one surface 5 flux is going, it means total flux is 6 pi, and this is equal to q by epsilon naught. So flux pi, that is flux through any one surface, is equal to q by 6 epsilon naught. We can use this thing only when charge is kept at symmetry. I mean, charge is maintaining the symmetry. अगर symmetry नहीं है, then we cannot use. Otherwise, we can. ठीक है? सो इस चीज को याद रखना। अगर ये चार्ज तुम्हारा इस सरफेस पे होता, यहाँ पे होता, इस पॉइंट पे होता, कोई भी कॉर्नर पे, देन कैसे इस क्वेश्चन को सॉल्व करते? सॉल्व करने का तरीका साई अभी चेक कर लो, क्लियर होगा। इसको सॉल्व करने का तरीका सिंपल है। केमिस्ट्री के क्लास 12th को याद करो, फर्स्ट चैप्टर, सेकेंड पार्ट, सॉरी फर्स्ट पार्ट का फर्स्ट चैप्टर, दैट इज योर solid state, right? So wahan pe we have studied, if there is atom kept on the corner, that atom is contributing 1/8 of its portion to the cubical thing, right? So agar ye corner pe hai, it's only 1/8 portion is inside it. So if you bring in more 7 cubes together, then this particular charge will be at the center of all those 8 cubes. डन है? सो उन 8 क्यूब्स के लिए क्या हो जाएगा? ये चार्ज एट द सेंटर। सो थ्रू 8 क्यूब फ्लक्स विल बी इक्वल टू क्यू बाई एप्सिलन नॉट. So through 1 cube, how much flux will go? Q by 8 epsilon. ठीक है. सो कभी कभी व्हेन योर चार्ज इज नॉट kept inside the closed surface, you can make it look like that by using your geometrical knowledge. जैसे यहाँ पे कॉर्नर पे है, so this charge is definitely not inside the surface. We cannot use Gauss law. So we can put seven more cubes in its surrounding such that charge is now inside the surface, and that too it is appearing to be at its center of the all those eight cubes. So in that case you can apply and calculate. Similarly अगर चार्ज यहाँ पे है, तो अगर इस पॉइंट पे है तो एक और क्यूब ऊपर से रख दोगे, then this charge will become inside the closest sphere. Only one more cube is required. So through those two cubes, flux will be equal to q by uh, epsilon naught. So through one cube, flux will be q by 2 epsilon naught. This is a question of symmetry completely. ठीक है. चलो अब ये बता दो जल्दी से इसका आंसर, आफ्टर दैट वी विल क्लोज. ठीक है. ज्यादा क्वेश्चन बचा नहीं है वैसे, इसमें कॉन्सेप्चुअल क्वेश्चंस है नहीं उतने. तुम लोग को क्वेश्चन इजी ही आ रहा है, सो आई हैव टेकन इजी वन, इजियर वन. अगेन यू जस्ट नीड टू यूज द फॉर्मूला. यस शशांक, दैट वाज करेक्ट. चलो नाउ लेट मी लॉन्च द पोल सो दैट यू कैन पुट योर आंसर्स हियर. चलो लेट मी नो एवरीवन. Okay, two answers, both are wrong. Three answers, all are wrong. क्या हो गया तुम लोगों को? सिंपल फॉर्मूला पुट करो यार. दिस इज अ कंडक्टिंग स्फीयर ऑफ रेडियस r and this is charged to a potential v. So v is equal to how much? V is equal to kq by r, right? Then the electric field at a distance r from the center of a sphere. So यहाँ से r distance पे what will be the electric field? So value of electric field will be equal to how much? kq by small r का square. ठीक है. एंड यहाँ से अगर आप हमें क्या बनाना है, फ्रॉम द इलेक्ट्रिक फील्ड का वैल्यू बताना है. डन है इन टर्म्स ऑफ वी. सो यहाँ से आप ध्यान से देखो, के क्यू को हम क्या लिख सकते हैं? वी आर लिख सकते हैं. सो दिस इज वी आर बाई स्मॉल आर का स्क्वायर. सो इलेक्ट्रिक फील्ड इज हाउ मच? वी आर बाई स्मॉल आर का स्क्वायर, क्योंकि in the option k is not given, right? So from here kq can be written as v into r. So same thing I have written here, v into r. So you will get correct answer as C. Yes, Raju, no. ध्यान से देखो. Everyone clear with this answer? Okay, finally got I one correct answer. That's great. ठीक है. चलो, so अभी तक क्वेश्चन करके क्या समझ में आया? समझ में सारे क्वेश्चन शेयर कर लूंगी. ठीक है. वॉट एवर क्वेश्चन इज देयर, you solve it from your side and then in the class I will discuss कौन कौन सा क्वेश्चन नहीं हुआ. So please check portal can solve left questions. ठीक है. डन है. तो तुम लोग करना उसको. चलो ठीक है. बाय एवरीवन, टेक केयर ऑफ योरसेल्फ.